Now we will see in the second case how area of a coil when it is changing leads to induced EMF. The area which is linked with the magnetic field keep on changing, then EMF is induced, current flows. Here we have made an arrangement. There are two rails. These are two rails. On these rails, this is a slider. The rails are connected on this side, and here we have put a slider. This slider can move like this. We apply certain force and start moving it with a velocity v. Okay. Now, after a very small time dt, this position changes to this new position, and how away it is away by a distance dx. Earlier from this end, this slider was at a distance of x. When we apply force, move it with certain velocity v, then after dt time it has moved a small distance dx. This is dx. Okay. Now, what is happening here? Initially, what was the flux linked to this area? Answer is magnetic field strength B multiplied by area. Area is a width into length, x multiplied by L. So, how much is the flux? B into XL. Flux in the rectangle is B into area, BXL. But when we push it, this length become x plus dx, the area become x plus dx into L. So, if we multiply this new area with B, what do we get? The new flux. Now the flux linked after the motion. How much it has moved? Answer, the distance dx. How much time it has taken? dt. So, in a small time dt, slider r moves by the distance dx. Okay. Now, the linked flux is the new area. This is the linked flux. What is the change in the flux? New flux minus old flux. When you do this minus, BXL is cancelled. What do we get? B dx into L. This is the change in flux. Due to change in flux, EMF is induced. EMF induced. EMF induced is equal to minus d phi by dt. Okay. How much is d phi by dt? This d phi is given by minus b L dx divided by dt. Now, what is this dx by dt? X displacement, t is the time, displacement upon time. Dx by dt is formula for velocity. This is velocity with which this force is sliding it. So, this dx by dt we can convert into v. So, this is minus BLV. This is formula for EMF induced, and this minus shows that it is opposite in direction, that is according to Lenge's law. So, what is magnitude of the EMF? Answer, magnitude of the EMF is BLV. This is magnitude of the EMF. Now, it depends whether this is more, this is more. According to its direction will be decided. So, we are concerned with the magnitude, and that is E is equal to BLV. Okay. So, remember, this is induced EMF. When this goes there, the area goes on changing. Now, if I want to know what is the EMF between these 2 points, this is the formula BLV. What is L? Length. This is responsible for changing the area. So, the one arm which is moving, these are not moving. So, I have not taken this length or this length. I have taken this length which is moving. So, the formula is EBLV, and here you see a very peculiar and compulsory thing. What is the direction of magnetic field? Answer, that is inside. What is the direction of length? Answer is, it is this side. And what is direction of force? This side. So this is magnetic field, this is the force or velocity of the conductor. This is the direction of electric current flowing in it, this way. So the current will be flowing in this direction, and this we will study in rules for the direction of the current. Okay, so but EMF produced by change of area is this, and in the next lecture we will see the direction of induced EMF. This EMF is due to motion of the rod, due to motion of this rod. Therefore, we call it motional EMF. Now, if there is a single rod and that rod is falling, even that will create an EMF across its ends, and that is what we are going to study in the next lecture. Thank you.